Hi everyone, my name is Zoe Diana, and today we'll be discussing plastic pellet consumption by sea anemones. Specifically, we set out to test the hypothesis that sea anemones, or Exaptasia pallida, can extract lead and tin additives from consumed polyvinyl chloride, or PVC for short, plastic pre-production pellets. So you may ask, why are lead and tin even in plastic to begin with? They're often used as additives in the plastic pre-production process to help prevent plastic from photodegrading and improve the longevity of plastic. So let's dive into the experiments that we did to test this hypothesis. We conducted two experiments, and we'll start with experiment one in the top left-hand corner at first. Anemones were offered one polyvinyl chloride or PVC pellet daily for 12 days. This pellet was unused, it was fresh, no biofilms, was never in the environment or anything like that. And control anemones were not offered any plastic pellets. All anemones were fed Artemia throughout the experiment, not at the same time that they were offered plastic, but separately, in order to keep them in a healthy state. We offered anemones plastic pellets, just as you'll see in this video here, by gently dropping a PVC pellet onto the tentacle ring of the anemones. And in this case, the anemone begins to consume the plastic pellet using its tentacles to guide the pellet into its mouth. Anemones can also reject plastic pellets. In that case, the anemone may use their tentacles to basically drop the pellet or guide it away from its mouth. They may ignore the pellet completely as well. So we also noted consumption or rejection of the plastic pellets if anemones refused to eat it. And what we found is that when an anemone was offered one pellet daily for 12 days in experiment one, they consumed between 4 to 11 pellets. So they ate a variable amounts of the pellets that were offered. We changed our experimental protocol in experiment two in order to try to get anemones to consume all of the pellets offered. So to do this, we put 10 microliters of shrimp homogenate. You can see in the photograph here, we sandwiched the pellet between these 10 microliters of shrimp homogenate and allowed it to dry, and then offered treatment anemones the one pellet daily for 12 days. And control anemones were just delivered 10 microliters of the shrimp homogenate. They were not offered any plastic. And in this case, in experiment two, anemones consumed all of the plastic pellets offered. So 12 of 12 pellets offered. Anemones were homogenized in 2 mils of DI water, and we quantified the amount of protein in anemones. We won't look at this data today, but happy to chat about that at a later time. And our endpoint for both experiment one and experiment two really though, is looking at metal quantification, specifically lead and tin, using inductively coupled plasma mass spectrometry. So let's dive into the results of experiment one first. In experiment one, we have control anemones in gray and treatment anemones, or PVC anemones, labeled here in this pink. On the y-axis, we have lead at the bottom and tin at the top. And in both cases, for both lead and tin, we found that treatment anemones had significantly higher concentrations of each metal, lead and tin, as compared to control anemones. And as a reminder, this is the case when anemones ate variable amounts of pellets, between 4 to 11 pellets each, and these pellets weren't flavored with the shrimp homogenate. These are just pristine pellets. So at first, we're seeing that anemones appear to extract lead and tin. In experiment two, anemones were offered the shrimp flavored plastic pellets, as you can see the little shrimp icon here. Control anemones in gray. In red, we have the treatment anemones that were fed PVC. And on the y-axis, we have lead and tin as well. And in this scenario, we're seeing similar concentrations of both lead and tin between control anemones and treatment anemones. All anemones were given shrimp, including the control anemones, the 10 microliters of shrimp. And we also quantified metals in the shrimp directly. I'm happy to chat about that more later on. And we found very small amounts. And since the shrimp was consistent between control and PVC, we're not thinking that plays a major role, at least in the metal concentrations. So what is going on here? In summary, anemones consumed multiple fresh PVC plastic pre-production pellets, as well as the shrimp flavored PVC pellets. In experiment 1, treatment anemones are extracting a measurable amount of lead and tin from PVC pellets. In experiment 2, treatment anemones are not extracting lead and tin from PVC pellets that were flavored with the shrimp homogenate. In experiment 3, which I haven't discussed, but this is our hypothesis that I'm actually testing right now in the lab, we're testing the hypothesis that lead and tin actually add flavor to the pellets, and then when anemones can choose the pristine PVC pellets, that treatment anemones will extract lead and tin from the pellets. So how are we testing this in the lab? I'm offering anemones a PVC pellet that is free of shrimp, pristine PVC pellet until it is consumed. So sometimes that means offering an anemone 1 pellet and they'll immediately eat it. In other cases, we're offering up to 30 pellets. That's the maximum number of pellets that I will offer them. And it can take 5 pellets until the anemone will consume it, up to 17. Sometimes they'll get to all 30 and will not consume a plastic pellet. But in this case, we think that when anemones have the opportunity to choose the PVC pellets that they're consuming, that we will see that treatment anemones will have higher lead and tin concentrations. So I hope to be able to share these results with you in the future, maybe at the next Ocean Sciences meeting. So thank you so much for the opportunity to present today. Also, thank you to my committee, my advisor, Dr. Dan Richoff, and the rest of my committee members as well, the collaborators on this project specifically. Megan Swenson played a great role in this project, Dr. Helen Chi Kim and Dr. Nelson Rivera Jr., whose photos you're seeing across the bottom here, conducted the metal quantification. Natasha Sawicki's, who is a graduate student at Hawaii Pacific University, kicked off these studies looking at anemones extracting metallic additives, originally on polyethylene pellets. And also our collaborators, Dr. Lee Ferguson and Melissa Chernick, who have helped me with some troubleshooting along the way. So there's my contact information. Please reach out, and I thank you for your time.